Determination of the equivalent resistance of two resistors connected in series. Aim: to determine the equivalent resistance of two resistors connected in series. Requirements: two unknown resistors, a rheostat, a voltmeter, an ammeter, a plug key, dry cell, or a battery eliminator, connecting wires, a sandpaper. Let us first draw circuit diagram. Procedure: select the voltmeter and the ammeter of suitable range. Note the least count and zero error of the voltmeter and the ammeter. Connect the electrical circuit as shown in the circuit diagram. Show the connections to the teacher or examiner. In the first step, connect the voltmeter across resistor R1. Put the plug in the key and adjust the rheostat to obtain the desired current in the ammeter. Note the readings of the voltmeter and the ammeter. Obtain 4 sets of reading for different currents. Then connect the voltmeter across resistor R2 and again obtain 4 sets of reading as above. Finally, connect the voltmeter across both the resistors. Here also obtain 4 sets of readings as above. Remove the plug from the key and disconnect the circuit. Observation number 1. Least count of the voltmeter is 0 volts. Number 2. Least count of the ammeter is 0 amperes. Number 3. Zero error of the voltmeter is 0 volts. Number 4. Zero error of the ammeter is 0 amperes. Now let us fill the observation table. It has columns, step, set of observations, ammeter reading I, which is observed and corrected, voltmeter reading V, observed, corrected, V upon I ohms. For R1, for first set of observation, ammeter reading observed is 0.15, ammeter reading corrected is 0.15, voltmeter reading observed is 0.45, voltmeter reading corrected is 0.45, so it is 3.0 ohms. For second set of observations, ammeter reading observed is 0.20, ammeter reading corrected is 0.20, voltmeter reading observed is 0.60, voltmeter reading corrected is 0.60, it is 3.0 ohms. For R1, here we have third set of observations. Ammeter reading observed 0.26, ammeter reading corrected 0.26, voltmeter reading observed 0.80, voltmeter reading corrected 0.80, it is 3.02 ohms. For R2 set of observations, for first set of observation, ammeter reading observed 0.30, ammeter reading corrected 0.30, voltmeter reading observed 0.90, voltmeter reading corrected 0.90, it is 3.0 ohms. For second set of observations, ammeter reading observed 0.35, ammeter reading corrected 0.35, voltmeter reading observed 1.10, voltmeter reading corrected 1.10, it is 3.1 ohms. For third set of observations, ammeter reading observed 0.40, ammeter reading corrected 0.40, voltmeter reading observed 1.20, voltmeter reading corrected 1.20, it is 3.0 ohms. For Rs is equal to R1 and R2 connected together in series, for first set of observations, Ammeter reading observed 0.28, ammeter reading corrected 0.28, voltmeter reading observed 1.68, voltmeter reading corrected 1.68, it is 6 ohms. For second set of observations, ammeter reading observed 0.26, ammeter reading corrected 0.26, voltmeter reading observed 1.58, voltmeter reading corrected 1.58, it is 6.07 ohms. For third set of observations, ammeter reading observed 0.27, ammeter reading corrected 0.27, voltmeter reading observed 1.62, voltmeter reading corrected 1.62, it is 6.00 ohms. Now let us see the calculations. Number 1. Mean resistance R1 is 3 plus 3 plus 3.02 upon 3, that is 9.02 upon 3, which is 3.00 ohms. Number 2. Mean resistance R2 is 3 plus 3.1 plus 3 upon 3, that is 9.1 upon 3, which is 3.03 ohms. Number 3. Total resistance Rs is equal to R1 plus R2, that is 6.03 ohms. Number 4. Mean equivalent resistance Rs when R1 and R2 connected together in series is equal to 6 plus 6.07 plus 6 upon 3, that is 18.07 upon 3, which is 6.02 ohms. The result is number 1. The equivalent resistance of two resistors in series is equal to 6.02 ohms. Number 2. The relation Rs is equal to R1 plus R2 is experimentally verified.
Please do not forget to like and subscribe the video.